GCP exam question. Cloud CDN and signed URLs. Welcome to the channel. Please consider subscribing. I produce videos daily covering a wide variety of cloud topics, focusing on networking. Also, hit the bell icon to get notified of new videos. Today, we're examining a Google Cloud Professional exam question that tests your understanding of Cloud CDN caching behavior with signed URLs. This is a crucial topic because signed URLs are commonly used to provide secure, time-limited access to private content, and understanding how they interact with CDN caching is essential for proper implementation. Let me read the question. Let's say you are designing the caching for an application using Cloud CDN. The application has a set of documents that should not be cached. You have created a publicly readable bucket, stored the documents in it, and configured a signed URL. Which of the following needs to be configured to prevent Cloud CDN from caching the contents of the bucket? This question presents an interesting scenario. You have documents in a publicly readable bucket, but you're using signed URLs for access control, and you don't want these documents cached by Cloud CDN. This is a common pattern for sensitive documents like financial reports, legal documents, or personalized content where you need access control but don't want the performance benefits of caching. The key insight here is understanding that even with signed URLs, Cloud CDN will still cache content unless explicitly told not to. Signed URLs control access, not caching behavior. The cache control header is what determines whether Cloud CDN caches the content or not. Before we analyze the answer choices, let's understand how signed URLs work with Cloud CDN and why cache control is critical in this scenario. Signed URLs are cryptographically signed URLs that provide time-limited access to resources. They contain authentication information in the URL itself, including an expiration time and a signature. When a user accesses a signed URL, Cloud CDN validates the signature and expiration before serving the content. Here's the critical point. Signed URLs and caching are separate concerns. A signed URL controls who can access content and when they can access it. Cache control headers control whether that content gets cached and for how long. These two mechanisms work independently. In our diagram, you can see the flow. When a client requests content with a signed URL, Cloud CDN first validates the signature. If valid, it then checks its cache. If the content is cached, and the cache control headers allow it, the CDN serves from the cache. If not cached or if cache control prevents caching, it fetches from the origin bucket. The problem in our scenario is that we do not want caching. Maybe these are sensitive documents that change frequently, or perhaps they are personalized for each user. Without proper cache control headers, Cloud CDN will cache these documents after the first valid signed URL request, and subsequent requests, even with different signed URLs, might get the cached version. This is why understanding cache control headers is crucial. The private directive tells Cloud CDN and any intermediate caches that this content is intended for a single user and should not be stored in shared caches. The public directive, on the other hand, allows caching by any cache, including Cloud CDN. Let's analyze the answer options to understand why setting cache control to private is the correct answer for preventing Cloud CDN from caching the documents. Option 1 is to set cache control to private and turn off signed URLs. This is incorrect because turning off signed URLs would remove your access control mechanism. If you turn off signed URLs on a publicly readable bucket, anyone could access your documents directly. The private cache control is correct, but disabling signed URLs defeats the security purpose. Option 2 is to set cache control to public and turn off signed URLs. This is the worst possible choice. Setting cache control to public explicitly allows caching, which is the opposite of what we want. Additionally, turning off signed URLs removes access control, This would make your sensitive documents both publicly accessible and cached by the CDN. Option 3 is to set cache control to private. This is the correct answer. The private directive tells Cloud CDN that this content should not be cached in any shared cache. It can only be stored in private caches, like a user's browser cache. This prevents Cloud CDN from caching the content while maintaining your signed URL access control. Option 4 is to set cache control to public, with a max age of 10. This is incorrect because public allows caching, even though a max age of 10 limits it to 10 seconds. While short-lived caching might seem like a compromise, it still allows documents to be cached and potentially served to unauthorized users during that 10-second window. For sensitive documents that should not be cached at all, this is insufficient. The key understanding is that private is specifically designed for user-specific content that should not be stored in shared caches like CDNs, while public explicitly allows such caching. Now let's look at how to implement the correct solution. Setting cache control headers in Google Cloud Storage can be done in several ways, and I'll show you the most common approaches. When uploading objects to cloud storage, you can set the cache control metadata using gsutil. The command gsutil-h cache control private cp document.pdf gs://mybucket/ sets the private cache control header during upload. This is perfect for automation and bulk uploads. For existing objects, you can update the metadata with gsutil set meta-h cache control private gs://mybucket/document.pdf. If you have many files, you can use the -r flag for recursive updates. gsutil-m set meta-r-h cache control private gs://mybucket/documents/. You can also set cache control programmatically using the cloud storage client libraries. This is useful when your application dynamically generates or uploads documents. The metadata is set as part of the upload operation. For signed URLs, you generate them using the process shown in the code example. The important point is that the cache control header is separate from the signed URL generation. The signed URL provides authentication, while the cache control header, which is already set on the object, controls caching behavior. One crucial detail: cache control headers must be set on the objects themselves in cloud storage. You cannot override them at the Cloud CDN level for individual objects. This is why it's important to set them correctly when uploading or to update them for existing objects. Also note that when you update cache control headers on existing objects, it may take time for cached copies to expire from the Cloud CDN in production scenarios. You might need to invalidate the CDN cache to ensure the new headers take effect immediately. Best practices and common scenarios. Let's wrap up with best practices for using signed URLs with Cloud CDN and explore common scenarios where you'd use different cache control strategies. For sensitive documents that should never be cached, always use cache control private, no store. The no store directive provides an extra layer of protection by instructing caches not to store the response at all, not even in encrypted form. This is ideal for highly sensitive content like personal health records or financial statements. For user-specific content that can be cached by the user's browser but not by CDN, use cache control private, max age 3600. This allows browser caching for performance while preventing CDN caching. This works well for personalized dashboards or user-specific reports. For content that can be cached but needs access control, you can actually use cache control public with signed URLs. The signed URL parameters become part of the cache key, so each unique signed URL gets its own cache entry. This works well for content like training videos or documentation that isn't sensitive but requires access control. Common pitfalls to avoid. Don't assume signed URLs prevent caching, they don't. Always explicitly set cache control headers. Don't rely on short expiration times in signed URLs for security if the content is cached. And remember that changing cache control headers doesn't immediately purge cached content. You may need cache invalidation. Testing tip. Use Chrome DevTools or curl with the iFlag to inspect response headers and verify your cache control settings are working correctly. Look for the XGOOG stored content encoding and cache control headers in the response. Remember, the goal is to balance security, performance, and user experience. For truly sensitive content that should never be cached, Cache Control Private is your friend. Thank you for your attendance. Please consider subscribing to the channel.